Ever since getting a 3D printer, I've been designing and 3D printing all kinds of camera gear and camera accessories. One of the first things I ever 3D printed was actually this wall hook that I think is designed to hold like a broom or something, but I found that they work perfectly for holding my tripods. I didn't design this. This is actually one of the few things that I didn't design, but I quickly discovered how amazing this was for holding my tripods. And so of course I couldn't just have one, and I printed a whole bunch. And then I scaled them up and printed even more. I have one over here holding this tube light. These are just so handy for quickly detaching and attaching my tube lights on the wall that I just put a whole bunch of them all over the place. If you do have a 3D printer, I will be putting links in the description to the digital files for most of the stuff that I'm going to show you in this video. Now, moving on to something that I actually did design myself, which is this matte box for smartphones. And here's why. This shot is being filmed on my iPhone 16 Pro, and right now there's a light over here that's lighting this scene. But a lot of that light is also hitting the camera lens, causing a really bad glare that's washing out the scene. Now, all I have to do to fix this is hold up something, even just my hand will work, to block the light so that it's not hitting the camera lens, and now I have a much cleaner, more contrasted image. This might seem like kind of a niche scenario, but as somebody who makes a lot of videos, I run into this problem fairly often, and I'm always jury-rigging something using random stuff to block the light. So I finally decided it was time to create a more professional solution and design a matte box specifically for smartphone cameras. So I got to work making the 3D model. I had a pretty clear vision in my head of how this design would look, so it came together really quickly and it was ready to be 3D printed. It only took about an hour to print all of these parts, and now it's time to assemble. These two pieces slide together to form the phone mount, and then on the back there's a spot for connecting a rubber band that creates some spring tension so that it clips tightly onto the phone. These flags are then going to connect to the front of this bracket. These just snap into place, and then there's a little bit of friction here so that they stay in whatever position you leave them in. And now for a quick test to see how well this works, here's what it looks like starting off with the flags all the way open so that they're not blocking any of the light. And now here's with one of the flags closed down, blocking out that glaring light coming from the left. Here's before, and here's after. Before, after. This is designed around my iPhone 16 Pro, but it really should work with just about any smartphone so long as it has a similar camera configuration with the camera in the upper left-hand corner. This does work with the zoom lens, the main lens, and the ultra-wide lens. All you have to do is adjust the positioning of the flags to accommodate whatever camera you're using. Also, on the bottom here, there's a built-in quick release plate, so it can directly connect to the top of a tripod. If you want to check compatibility with your tripod, this connection point is 38 millimeters across, which is a pretty standard size and should work with a lot of different tripods. Next up, I tried actually printing a camera lens for my Canon camera. I guess this technically isn't really a lens because there's not actually any glass inside of this. It's more like a photon delivery device. This thing is really fascinating to look at, and you can see the light shining through it from different angles. It's basically just a very fine grid, but unlike a window screen, for example, this has depth to it. So that grid runs the entire length of this cylinder, and then on the back there's a Canon RF lens mount. So this can actually attach directly to the front of my Canon camera. I think I might actually be the original inventor of this lens. I've never seen anybody else 3D print a lens like this one. Maybe for good reason, because it does have a lot of limitations. For example, there's no way to focus it, so it only takes pictures of things that it's really close to. But one of the kind of cool limiting factors of this lens is that instead of taking normal pictures, it actually creates these pixel art style images that kind of look cool. I also made this one other camera lens as well. This one actually has a lens in it this time, but unlike a normal camera lens that would be shaped like this one is a Fresnel lens, which is shaped like this. So again, a very experimental lens here that I was sure was not going to take great photos, but I was just still curious what taking photos through a Fresnel lens would look like, and 3D printing allowed me to experiment with that. This one does actually have an adjustable focus. And here's some of the photos that I got using this lens. Both of these lenses are something that I haven't released files for, at least not yet, just because they're so experimental and niche, and I'm really not sure if anybody else is interested in them. So if you are interested, leave a comment below and I might make a tutorial on how to put these lenses together. But now moving on to some of my more practical 3D prints, we have this lens adapter that I created for the Insta360 Go 3S, which allows you to attach a macro lens onto this action camera. And with this, I was actually able to capture some really cool results. If you want to connect an older Canon EF lens to a newer EOS R camera body, you're going to need to buy this adapter, which is kind of expensive. You could get an off-brand one for half the price, but I decided I wanted to save even more money and just design and 3D print my own adapter. Designing this was pretty simple in theory, but ended up taking me a while because I had to do so many precise measurements on both the camera and the lens to make sure all of the parts were exactly the right size and in the right place. But it did finally all come together, and my Bambu Lab A1 mini printer did a beautiful job of printing it out. Besides just making this a functional part, I also made sure that it was optimized for 3D printing, and I was actually able to design it to print entirely without support material. Clicking this into place, it fits perfectly on the EOS R camera body. I even added a diamond-shaped pattern to the outside for aesthetics, and there's even this little spring latch mechanism on the side here that holds the lens in place. This prints as a separate part, and then by compressing the spring, you can snap it into place on the adapter. And now when attaching the lens to the adapter, it clicks into place and it won't come off unless you pull back on the latch first. And now for less than $1 worth of plastic filament, I have my 24mm EF lens attached to my Canon EOS R8. Now, because this is just a piece of plastic without any electronics in it, I am losing my autofocus, and the camera also doesn't recognize that there's a lens attached to it right now, so to actually get it to take any photos or videos, I had to go into the menu settings, find the release shutter without lens option, and turn that to on. And here's what the video footage actually looks like using this lens setup. I absolutely love how this 24mm lens looks, but it's a bit annoying to have to manually focus it when I'm filming videos. I really don't care when I'm taking photos, and mostly I'm just really excited to start being able to use some of my older Canon lenses on my Canon R8. If you're a professional, you should probably just buy the actual adapter. But if you're just a hobbyist, this is a really great way to start seeing how some of your older lenses look on your newer camera for super cheap. The other day, I strapped my Insta360 Go 3S action camera onto a kite to get some sweet aerial shots, which actually ended up looking pretty cool right up until this moment right here. The lens took the brunt of the impact during this crash, and it got pretty scratched up. Luckily, this camera isn't ruined though, because the lenses on here are actually interchangeable. So for $20, I could order a new one to replace it. But while I was waiting around for the new one to be delivered, I decided I was going to design and build some sort of camera cage or shell to go on this to help prevent the lens from just getting scratched again in the future. So I got to work, and after lots of careful measuring, experimentation with various shapes and configurations, and printing lots and lots and lots of prototypes, I now have something that is not only functional, but I think also looks kind of good at the same time. So now this camera is ready for action. And the last thing that I have here is not entirely 3D printed, but it definitely would not have been possible for me to make without 3D printing, which is this motorized cable cam. I'm gonna be using it with the Insta360 Go 3S action camera, but it will be capable of carrying other small action cameras as well. To start off, I'm going to wire together my electrical components, which consist of just 3 parts: the motor, a speed controller, and a rechargeable battery that can all be purchased on Amazon for under $30. And I will put links for each of these parts in the description. The wiring for this is super basic. I'm just gonna solder a wire to both positive and negative on the motor, and then connect the other ends of these wires to the output on the speed controller. and then just add wires to the positive and negative inputs on the speed controller, which will then plug into the battery. And that's literally all there is to it as far as the electronics are concerned. So now when I turn the dial, it will power on the motor, and adjusting the dial will change the speed of the motor. And now it's time for the fun part, actually designing the zip line, which I'm planning on 3D printing as much of as possible. Now at this point, I don't even know exactly what it's gonna look like, but I'm just gonna start off by measuring each of the parts and designing some sort of housing that they'll all fit inside of, and then go from there. And here is what I came up with. And now that this is ready, it's time to go fire up the 3D printer. This turned out really nice. The controls fit perfectly, the battery compartment is perfect, the slot for the motor and the wheel that attaches to the motor have this really nice friction fit, so they don't need any glue to stay in place. And the only thing that's not 3D printed on this zip line are the two metal studs that needed to be really smooth so that the wheels would spin nice and freely. On the bottom, there's a notch for sliding in a 1/4-inch screw, which I can then attach the mounting plate for the Insta360 Go 3. And now I'm ready to go try this thing out.